A very welcome to all of you joining us from all around the world. So, as previously stated, I am Sanchayan Sarkar, the founder of Trishul Observatory, and absolutely thrilled to be both your host and one of the speakers for our anniversary special webinar, Trishul Observatory and a Year Among the Stars. So, it's an incredibly special moment for me and for the entire Trishul Observatory family to see so many passionate individuals, space enthusiasts, students, and researchers joining us today as we celebrate our first anniversary. So, I would request all of you to confirm whether my screen is visible or not.
Yes, visible.
Thank you, sir. So, once again, a very welcome to all of you to our today's webinar, Trishul Observatory, A Year Among the Stars. So, Trishul Observatory began as an initiative under the wonderful SA Citizen Science Group, which, as many of you know, is the largest citizen science group in India and a fantastic international platform for scientific collaboration. So, this journey has been fueled by the incredible support of our respected Sobhan Acharya sir, the visionary founder of SA Citizen Science Group. Sir, your belief in this initiative has been our guiding star, and we are immensely grateful for your continuous encouragement. So, now before delving into our today's webinar, I want to acknowledge our collaborators in this webinar, that is SA Citizen Science Group. As previously told, that SA Citizen Science Group, as many of you know, that it is the largest citizen science group in India. Secondly, Konnagar Space Lab. It is an international citizen science group and an initiative of SA Citizen Science Group, just like Trishul Observatory, and, and Hexstar Universe, an innovative edtech platform dedicated to space science and technology education. Its mission is to make space science accessible and affordable by facilitating learning from the world's top 1% experts. So, astronomy. What is astronomy? In Trishul Observatory, basically, our uh, engagement and our activities are basically centered to this particular subject, that is astronomy. So before knowing about Trishul Observatory and its works, we have to know what is astronomy, what is a subject that Trishul Observatory is practicing, or the activities of Trishul Observatory are centered to which subject, what is it, what is astronomy about. So, astronomy is a natural science that studies celestial objects and the phenomena that occur in the cosmos. It uses mathematics, physics, and chemistry in order to explain their origin and their overall evolution. Objects of interest in astronomy include planets, moons, stars, nebulae, galaxies, meteoroids, asteroids, and comets, etc., as pretty much all of you know. Now, what are the primary subsections of astronomy? What are the primary branches of astronomy? So, you see that as we discussed just uh, now, that astronomy is the natural science that studies celestial objects and the phenomena that occur in the cosmos. Similarly, astronomy can be divided into four primary branches, that is astrophysics, astrochemistry, astrobiology, and astrogeology. What are they? Astrophysics is nothing but the study of how the laws of physics apply in space. Astrochemistry is a study of how molecules form, react, and interact with radiation in space. And astrobiology is basically just the search of life outside the Earth, that is, the search of extraterrestrial life. And astrogeology is the study of terrains, rocks, and materials in space and in other celestial bodies. Now, human curiosity and timeless fascination with astronomy. You see that the curiosity of humans and the fascination of humans, excuse me, with astronomy is not built in a day. It was from the ancient times when the humans developed their curiosity on astronomy. So, astronomy in ancient civilizations. The night sky has always fascinated the curious minds of humans, that is, us. The fascination of astronomy in the minds of humans started to grow from a long time ago. Since ancient times, humans have observed the night sky to track time, navigate, and understand natural phenomena. So, from ancient times, the astronomy was used by humans for various important tasks like tracking the time, navigating the sea, and understand various phenomena, etc., etc. Oh. People from ancient civilizations, as for example Babylonians, Egyptians, Indians, Chinese, and Mayans, practiced astronomy. The scientific revolution and beyond. The invention of telescope in the 17th century changed everything. Scientists like Galileo, Kepler, and Newton revolutionized our understanding of planetary motion and gravity, laying the foundation for modern astrophysics and modern astronomy. So, in this table, there are three scientists from the 17th century, three famous physicists from the 17th century, and who laid the foundation of modern study of astronomy and astrophysics. So, firstly, we have Galileo Galilei. We all know uh, his contribution in astronomy, that is, he invented the telescope. So, and he lived between 1564 to 1642. Secondly, we have Johannes Kepler. Sorry. Secondly, we have Johannes Kepler. He lived between 1571 to 1630. His contribution is in astronomy is that he introduced the Kepler's laws of planetary motion. And in third place, we have Sir Isaac Newton. He lived between 1643 and 1724. And we all know that he introduced the universal law of gravitation, which works, which was a great solution to the question that if an apple falls, why doesn't the moon fall? But later on we get that there are some limitations of this law. It's not universal, but still, at that time when calculus uh, was not developed in a very pure way, or calculus wasn't introduced properly at that time, Sir Isaac Newton gave us the mathematical uh, relation which can answer to the question that why an apple falls but the moon doesn't fall. Now the space age and modern exploration. With the launch of Sputnik in 1957 and the Apollo moon landings, humans' interest in space exploration reached new heights. Today, powerful telescopes like the Hubble Space Telescope and James Webb Space Telescope, that is a JWST, allow us to explore galaxies billions of light years away. Now, the future of human interest in astronomy, although the future is unpredictable, we can say that with growing interest in Mars colonization, black hole studies, and a search for extraterrestrial life, the fascination with astronomy continues to evolve. Astronomy is more than just science, it's a journey of discovery that unites humanity in a quest to understand the universe, and through citizen science, anyone can be a part of this grand adventure. You see, astronomy is not just a subject or a field of study that we practice. It's a passion. It's nothing but the result of human curiosity, which gave us insightful analysis into the celestial objects like star, nebulae, planets, etc., etc. And that curiosity is only the thing that formed this new paradigm of astronomy. Now, here comes citizen science. What is citizen science? As previously stated, that Trishul Observatory is an international citizen science group where we encourage our members to practice citizen science projects. Now, what is citizen science? Citizen science is a research conducted with participation from the general public or amateur or non-professional researchers or participants for science, social science, and many other disciplines. Now you see that citizen science is not only astronomy centered. Citizen science is available in various platforms and citizens the prominence of citizen science can be seen in various other studies like the social science and uh, ecology, biology, conservation, and uh, various other disciplines. So there are variations in the exact definition of citizen science with different individuals and organizations having their own specific interpretations of what citizen science encompasses. You see, just like we speak in different languages, the meaning of citizen science varies from person to person. So citizen science is used in a wide range of areas of study, including ecology, biology, and conservation, as told previously, that it's not only astronomy centered. Uh, Fields of study or areas of study, including ecology, biology, and conservation, health and medical research, astronomy, obviously, astronomy, media and communications and information science uses citizen science for advancing their contribution in humanity. So, what are the applications of citizen science? Now, we know what is citizen science, but where it is needed and what is its applications, how it is how it is applied in our day-to-day lives and in research works. So there are different applications and functions of citizen science in research projects. And citizen science can be used as a methodology where public volunteers help in collecting and classifying data, improving the scientific community's capacity. Citizen science can also involve more direct involvements from the public, with communities initiating projects, researching environment and health hazards in their own communities. Now, you see, the primary need for citizen science is nothing but the huge volume of data available, and and basically the need of citizen science comes from the huge collection of data as previously told, and when all of that data needs to be shortlisted. Now, when uh, when professional scientists come to a situation like this, so they do what? They train the public, and to do the primary analysis of the data and get the data shortlisted. Once the data is shortlisted, they can analyze the shortlisted data, which has a relatively reduced volume, so that they do not miss the minute details. So now, uh, participation in citizen science projects also educates the people about the scientific processes and increases awareness about different topics. Some schools have students who participate in citizen science projects for this purpose as a part of the teaching curriculums. So just like Ayub Academy, we have Ayub Academy with us today in this webinar. So Ayub Academy is an educational institution in Jharkhand. It provides free education and free lodging of various students. And also, Ayub Academy teaches their students how to participate in citizen science projects and encourages their participation in citizen science projects. In the field of citizen science, Ayub Academy is collaborating with Trishul Observatory and SS Citizen Science Group, and they are continuously participating in citizen science projects like international astronomical search collaboration, asteroid search campaigns, that is the IASC asteroid search campaigns, and various other citizen science projects. Now, contribution of citizen science in astronomy. What are the contributions of citizen science in astronomy? So, citizen science plays a crucial role in modern astronomy by allowing enthusiasts, students, and independent researchers to contribute to real scientific discoveries. With the increasing amount of astronomical data, professional astronomers rely on citizen scientists to help analyze, classify, and identify celestial phenomena. Key contributions of citizen science in astronomy. Firstly, we have asteroid and comet discovery. Citizen scientists participate in asteroid search campaigns like IASC, International Astronomical Search Collaboration, helping detect near Earth objects and track new asteroids. Secondly, galaxy classification and dark matter studies. Projects like Zoo allow volunteers to classify galaxies, contributing to the understanding of galactic evolution and dark matter distribution in intergalactic medium. In third, we have uh, exoplanet detection. Citizen scientists, excuse me, citizen scientists analyze light curve data from missions like Kepler and TESS, that is TESS, to identify exoplanets orbiting distant stars. In fourth place, we have supernova and variable star monitoring. Amateur astronomers play a key role in detecting supernovae and tracking variable stars, aiding in the study of stellar evolution. In fifth place, we have SETI and extraterrestrial life research. Projects like the Are We Alone in the Universe involve public in scanning radio signals for possible extraterrestrial communications. So, in this project, Are We Alone in the Universe? In this project, what we do, what citizen scientists do is that uh, they get some RFI signals and they analyze those RFI signals, that is the radio frequency interface signals, that could be and a possible candidate for radio technosignatures of extraterrestrial life. Now, why it matters? Why the contribution of citizen science in astronomy matters? Citizen science is essential in astronomy because it bridges the gap between professional research and public participation, allowing anyone with curiosity and dedication to contribute to real scientific discoveries. With vast amounts of astronomical data generated by telescopes and space missions, professional astronomers alone cannot analyze everything. Citizen scientists help there by classifying galaxies, tracking asteroids, discovering exoplanets, and monitoring transient celestial objects, celestial events like supernovae and kilonovae, etc., etc. Their contributions not only enhance the efficiency of research but also lead to groundbreaking findings that might otherwise go unnoticed. Moreover, citizen science fosters global collaboration, inspiring students, enthusiasts, and independent researchers to engage in astronomy, making science more inclusive and accessible. By participating in projects like asteroid search campaigns, galaxy classification, and Are We Alone in the Universe, citizen scientists play a crucial role in expanding our understanding of the universe. Now here we have Trishul Observatory, our citizen science group, Trishul Observatory. So Trishul Observatory is an international citizen science group dedicated to advancing astronomy and astrophysics research by engaging individuals from diverse backgrounds. Our community unites students, professionals, and passionate enthusiasts worldwide, uh, providing them with opportunities to participate in meaningful scientific projects by fostering a collaborative environment. We empower individuals to contribute to real astronomical discoveries, regardless of their academic or professional background. So, as told previously, that this is our anniversary special webinar, and Trishul Observatory uh, just turned uh, just uh, experienced its first birthday like a month ago. So we created Trishul Observatory in collaboration with the SS Citizen Science Group on 1st March, and today is the 30th March. So Trishul Observatory is going to complete its journey of 11 months. So today marks out not just a year since Trishul Observatory's inception, but also a celebration of the power of citizen science in unraveling the mysteries of our universe. So during this webinar, we will delve into the exciting world of ongoing and upcoming citizen science projects practiced in Trishul Observatory, and showcasing how each and every one of them you can actively contribute to real time astronomical research. So it's a fantastic opportunity to get hands-on experience and make a tangible impact on our understanding of the cosmos. So now, what's our mission? At Trishul Observatory, we believe that science thrives on a collective effort and curiosity. Our mission is to enable real time astronomical research. We provide a platform for individuals to actively engage in scientific studies, from asteroid tracking to galaxy classification and astrophotography, and fostering collaboration and knowledge sharing. By bringing together experts, students, and citizen scientists, we create a learning ecosystem where knowledge is exchanged freely, driving innovation in the field of astronomy. Inspire the next generation of astronomers and space enthusiasts through the hands-on experience, mentorship, and research initiatives. We aim to ignite a passion for space science, nurturing future astronomers, astrophysicists, and space researchers. Now, Trishul Observatory is more than just an organization. It's a global community that empowers individuals to contribute to the vast and ever expanding field of astronomy. Whether you are a beginner or an experienced researcher, you have a place here to explore, discover, and make an impact in the universe. Now, we are going to discuss some of the projects that we practice in Trishul Observatory. In Trishul Observatory, we encourage our members to participate in various citizen science projects and initiatives and engage in real time astronomy research. Some of such projects are International Astronomical Search Collaboration, that is IASC. So, the International Astronomical Search Collaboration is a citizen science program that provides high quality astronomical data to citizen scientists around the world. These citizen scientists are able to make original astronomical discoveries and participate in hands on astronomy. This service is provided at no cost. Asteroid search campaigns are the primary focus of IASC. A campaign is basically a month long event in which teams search for asteroids. Now, what are the requirements for participating in the International Astronomical Search Collaboration asteroid search campaigns? Nothing but a Windows PC. Obviously, only Windows PC, neither Linux nor Mac or any other operating system, because the software that we use in this citizen science project, that is the Astrometrica software, is only supported in a Windows PC. Secondly, we should have a stable internet connection, preferably the broadband connection, as you see that the broadband connections are very much stable. That is, and also the Astrometrica software and the IASC homepage consumes a lot of data, and that is why it's preferred that to use a broadband connection. In third place, we have excuse me, Astrometrica software installed in our computer system. So to engage in this project, we should have the Astrometrica software installed in our laptop or desktop, whatever, in our computer, in our that is in our PC, and we should be a part of a team that is registered in an asteroid search campaign organized by IASC. Now we will see that how to participate in this citizen science project. To participate in citizen science project, just first of all, what we have to do is to just go to the IASC website. Now you can have a screenshot or note it down. The IASC website, that will take you to the homepage of IASC. That is iasc.cosmosearch.org. Just open a new tab in your browser and type iasc.cosmosearch.org and hit enter, and you will be on the homepage of IASC. There you will get various tabs on the top, and from those tabs you have to click on the Astrometrica tab. Once on the Astrometrica page, click on Astrometrica setup and download the desktop. Download to the desktop. Now, once you click on that Astrometrica setup link, one pop-up may appear that is an insecure download block that your browser will show to you that this file is insecure. Why? Because in most cases, the connection between your computer and the IASC website is not secure, is not considered secure by your browser, but it's secure. You can download that software setup file, that astrometrica.setup file from that particular website. So you have to ignore that message and click on keep, and it will be downloaded automatically into your computer. After once it's done, just open your uh, Windows File Explorer and go to the downloads and double click on the Astrometrica setup file. And from there, you will get one installation window of Astrometrica. Just click on uh, next, then again next, and after that, click on finish. In the second step, you will get that you will be asked that you want the software to be stored where. That is in desktop or in Windows C or in Windows, that is in C drive or D drive or any other drive that you have. So it will ask that. So you may choose another location, or you may keep the default location that is in the Windows C, and click on next. After that, it will automatically install all the files, and then you have to click on finish. Now the this CMD window will pop up. After some time, this CMD window will pop up. This will take several minutes to complete as it updates the Minor Planet Center database. Now, after it's done, you will get one blue colored icon on your desktop, that is Astrometrica software icon. Double click on that, and another CMD window, like as it is given in the image, just like that, will appear in your uh, in your desktop, right in front of your screen. And it will update the MPC data, Minor Planet Center database, and it will also update uh, the MPC ORB database, and various and the catalogs and everything that the software uses. So don't close that. But you have to note one thing, that is that this update, that is a second update, will be performed each time you start Astrometrica. Now, after it's done, the Astrometrica software will automatically be opened, and you will get an interface just like the image given in the sixth option, in the sixth option, you see in the sixth option. So just like that, you will get one interface and one message that MPCORB report, MPC report.txt, photo report.txt, and astrometrica.log already exists. Replace existing files. So it's a confirmation message, and you have to click on yes to clear the MPC report. Now, after you install Astrometrica for the first time in your computer, you must register for a free unlimited use. For that, click on help window, click on help tab, and then click on registration, and then type the license and key. The license and key is provided by email only to citizen science groups participating in an asteroid search campaign. However, you can still use Astrometrica on a limited basis for 100 days without a license and key. Now, instructions for using Astrometrica. You have to note one thing, that is that you are the key to the success of your citizen scientists in the search for asteroids. So as previously stated, that in IASC we search for near Earth asteroids, that is NEAs. What are they? NEAs are basically near Earth objects that are specifically asteroids. So there are also near Earth objects, but there are not comets or any other near Earth objects, but they are specifically asteroids. And what are near Earth objects or NEOs? So near Earth objects are asteroids and comets whose orbits bring them close to Earth's orbit. So technically, in technical terms, so they are any solar system body orbiting the sun whose closest approach to the sun is less than 1.3 times the Earth's sun distance. Now, there are two things you must master, and if you do, your citizen scientists will make important measurements of near-Earth objects and might detect a main belt asteroid or two as they participate in an asteroid search campaign. So What are they? You must be able to use Astrometrica to conduct a manual search, and you must be able to distinguish between a true and false signature for moving objects. Once you have Astrometrica up and running on your computer, it will take a couple of hours of your time to master the above tasks. So you will not master them immediately. You will need a couple of hours or days or even weeks to master the above tasks. But you must prepare yourself ahead of time before receiving image sets in an IASC asteroid search campaign. Uh, so in this presentation, you will find the instructions on how to do a manual search using Astrometrica. You will learn how to measure true signatures and determine if they are unknown objects. To learn how to okay. Now, so to learn how to distinguish between a true and false signature for a moving object, you need to review the document entitled Signature Guide. And this is a part. This signature guide is a part of the Quick Start Guide file. So you will get the Quick Start Guide file from IASC's homepage. Just click on Just go to IASC's homepage. Click on Astrometrical tab, and there you will get the link for downloading Quick Start Guide. From there, you can get a detailed instruction in using Astrometrica and how to like how to differentiate between a true and false signatures. Now, starting Astrometrica manual search. Start Astrometrica from the desktop icon as previously told. The following is the Astrometrica toolbar with its various functions. Now, you see there is a blue wrench icon, that is the edit program settings icon. There is load images options. So here you can see that I have marked the important options that you are going to need for your asteroid search campaign, for the analysis of image sets of your asteroid search campaign. Now here is a blue wrench icon, that is the settings option. At first you can see, and after that we have load images icon. There's the green crosshair option, that is the data astrometric data reduction. After that, there's a blue option, that is the stack images. After that, view MPC report. After that, close all images. After that, you have known object overlay. You have zoom in or zoom out option. You have blink current images option. You have stop blinking option. You have single step forward or single step backward option, and you have the play start blinking option. Now, Astrometric may ask you to override the MPC report. Click yes. Just in the previous slide, I showed you that you may get a message right from Astrometrica, which asks you to override the MPC report. Just click yes only if you have completed the MPC report from the previous session. So previously, if you have if you were analyzing an image set and had the MPC report saved in your computer, then only you should click on yes. Otherwise, click on no to get that to get the previous MPC report. Make sure the configuration file is the correct file for the images. The name of the configuration file is found on the bottom right hand corner of the screen. It should use PS1 configuration for all of the images, because images come from the Pan-STARRS telescope. Now, you see that not in all cases, in most of the cases it's PS1, but not in all cases. There's PS2 configuration too. So when you install the Astrometrica software for the first time, you may get another configuration file, but that's not applicable for international astronomical search collaborations, asteroid search campaigns. Only PS1 and PS2 configurations are applicable for the asteroid search campaign. And how to check that? Basically, I mean, how to know that which configuration file you should use, PS1 or PS2, to check that to make sure that you should use the PS1 or PS2 file. You should have you should check the first three initials of your image set that you are analyzing. So when you are analyzing one image set, then in the name of the image set, the first three initials will tell you whether the image set is from the Pan-STARRS 1 telescope or the Pan-STARRS 2 telescope. That is PS1 or PS2. If it is written PS1, then you should use PS1 configuration, and if it is PS2, then you should use PS2 configuration. To change the configuration file, select Settings, the blue range icon on the toolbar, then click Open and select the correct configuration file from the Settings folder, and then click OK. Make sure your team has downloaded the newest version of the PS1 and PS2 configuration file from your team page if you are participating in an asteroid search campaign. So the newest version of the PS1 and PS2 configuration files are always given in the team page. Uh, on behalf of which team you are participating in the asteroid search campaign. On the IASC website, now the next step is on the IASC website. Download your image sets from your team page and unzip the images onto the desktop or folder of your choice. In Astrometrica, select Load Images and on the toolbar and load your unzipped image set. Always you have to remember that in each image set there are 4 images, and these 4 images are captured uh, in a 10-minute interval from the Pan-STARRS 1 or Pan-STARRS 2 telescopes, and then you have to click on Open. Now, to download the image sets, when you have to go to your team page. Now, when you are participating in an asteroid search campaign on behalf of your team, on behalf of a team, your team leader will give you some relevant details. That is a team name, team, the country on behalf of which the team is participating, uh, the campaign name, and uh, also the uh, license and key to register in Astrometrica. So when you have all those details, and also the email register with IASC and a password to log into the website of IASC. So when you go to the website of IASC, you get various tabs as stated previously, and there you have to do one thing. That is, just first of all click on the login tab. There you will get a login window, and you will get one email and password section. In the email section, you have to enter the registered email provided by your team member. So this is the email that is registered with IASC for the particular asteroid search campaign in which your team is participating, and then you have to type the password. So after that, click on login, and you will be logged into your team's page, and you will be logged into the IASC's website. From there, you have to click on the campaigns tab, and from there you will get a list of all the current ongoing campaigns. From there, you have to select the campaign where your team is participating, and click on that. Once you click on the name of the campaign where your team is participating, you will get the list of teams which are participating in that particular campaign. Now, in most cases, there is the My Team section, and there you will get your team's name. Just click on that, and you will get into your team's page. From there, you have to download the image sets that your team leader has assigned to you to analyze. Now, after that, as told that you have to open Astromet, and from there you have to download the image set, and the image set will be in zip folder. You have to move that zip folder and unzip it in a desktop or any other folder which you wish to use. And after unzipping the folder, you have to go to the Astrometrica software, and in the toolbar option, click on the File tab and click on Load Images. From there, the Load Images window will appear. From there, you have to go to a particular folder where you have stored your image set, and just open the folder, and we have to select all the 4 images and click on open, and the image set will be opened in the software. Now, once you have opened the image set in the software, select data reduction on the toolbar and click on OK in the box that appears. Now, data reduction, you see that in the image set there is a large content, there's a large volume of data, and that data needs to be deducted. So you see there are stars, planets, and many other objects, but you need only near Earth objects. That is why the data reduction of process should be done. And to continue to the data reduction process, just you can click on the green crosshair option, that is the data reduction option from the toolbar, or press Control A, or go to the astrometry tab and click on astrometric data reduction. Now the data reduction window will appear from and in the first there will be one section named object. There you have to specify which data you want to keep and which data you want to be deducted. I mean, you have to write the name of the name of the object, the data of which you want to keep in the 4 images, and you have to and the other data will be deducted. So now in this campaign we do not have a specific object like that. That is why we want to do the data reduction of the overall piece of sky that has been captured in the given image set. That is why we will not do anything there, and without changing anything we will click on OK. This function will find reference stars in your images. Now an error window may appear just like in the image given below. You see, if this happens, select option 2, automatic reference star match. Option 2 will solve most issues. If it doesn't, then just click on the third option and click on OK. Now, after the data reduction has been done, the data reduction results window will open. Now, this window is not that much important. That is why you can close it. Now, the next step is the known object overlay. So this will take a few minutes. So you have to be patient. Now, what this option does is that it sorts out all the known moving objects that has been measured earlier by citizen scientists, and that those objects will appear in a image set with a red box. Now, you see that here you can see that before the zoom in and zoom out options there is a null object overlay option. So from the toolbar you have to click on that, or you can go to the astrometry tab and click on known object overlay. Now now to spot moving objects you need a video or animation or a graphic just like that. So and that is why you have to go with the blink current images option, so that all the 4 images are being played on the software, so that you can spot the moving objects in the image. So here you can see that the blink current images option is there. Before the blink frequency, you see that one is written. Before that one, in the right side, in the right side, one is written, and in the left, in the immediate left of one written in the toolbar, there is the blink images option. Click on that, and the 4 images will be played on your software. And for the convenience of your site, of each of the grids, each of the squares in the images, you can zoom the image set twice. So zooming in twice is usually a good start. So now you have to visually scan the blinking image for moving objects. Now you have to refer to the signature guide for a comprehensive study of how to distinguish between true and false signatures. Now also you can try a grid search method, that is you can first of all you can visually scan the first square, and then the second square and third square. So now basically the image, all the four images are divided into 4 by 4 grids. So first of all, what we do is we have to visually scan the whole image set. That is why uh, we go to the first square, that is the row 1 and column 1 square. So we call this first square as R1 C1, row 1 C1, that is row 1 column 1. After that, the square below it, that is row 2 C1. After that, row 3 R3, that is sorry R2 C1. After that, R3 C1. After that, R4 C1. After that, R1 C2. After that, R2 C2. After that, we go for R3 C2. After that, we go for R4 C2. And just like that, we complete all the squares. Now, measuring an object. When an object, when a moving object is detected, we have to stop we have to stop the blinking. We have to stop blinking the current images. That is why we have to click on the blink stop blinking option. You can see that here it is just to the immediate right of the one written in the right side of the toolbar. That is the stop blinker option, that is, or also known as a stop blinking option. Just click on that. That's a red circle. You have to click on that, and the images will be the images will not blink more. Now, you have to measure that object. You have to begin by forwarding to image 1. So just beside that stop blinker option, there is forward or forward or back buttons that take you to the previous image and next image. Now, first of all, you have to move to image 1. Then you have to center the object with a crosshair and click on the object. So your mouse pointer will become a crosshair, and you have to center the object with a crosshair and click on the object. Then click on the dotted button next to the object designation and check the table of nearby objects. So here you see that when you click on that, click on the moving object, you will get the object uh, identification window. uh, uh, Object identification window. Uh, Sorry, the object is here. Yeah, here. Yes, the object identification window, and there you have to in the object designation section, you have to click on the three dots. That will open another window of containing the list of all the nearby moving objects, and the first object in that list is the nearest moving object, and you have to check the DRA and DD value of that of the nearest moving object. And if the DRA and DD value are between the range of minus 0.2 and plus 0.2, then it is a known object, and you have to click on OK. And you have to accept that. Now, if the values do not match, then most probably, it's not a known object, and it's an unknown object. You have to designate it differently, and uh, just like you have to measure no the objects. Now the known object overlay option shows all the known objects recognized by by the software system in red squares. So you have to measure all those known objects, and but you have to but make sure to verify that whether it's a uh, true signature or false signature. And after that only you have to click on accept, because in some cases that the software system is unable to detect true signatures or false signatures. And uh, although there are red squares and they are moving, but there are no objects nearby, no there are no objects nearby or inside them. Now, that is now here is the outcome too, where the DRA and DD values are not matching. In that case, you have to give a new designation to the object, and this designation is generally a combination of 3 letters and 3 numbers, minimum 3 letters and 3 numbers, and sorry, and 3 letters and 4 numbers, and then you have to hit accept. Now you see, these are object discovery codes, and these codes will be given to you by your team leader when you participate in an asteroid search campaign organized by IASC on behalf of a team. Now you have to repeat this same procedure for image 2, 3, and 4 by forwarding into image 2, and then to image 3, and finally to image 4, repeating the same procedure as with image 1. And you have to continue searching the image until all asteroids have been measured. Now, the Minor Planet Center report. One MPC report must be prepared for each image set and submitted on IASC team page. If more than one group of citizen scientists analyzes the image set, only submit one report listing up to 5 people. In Astrometrica, you have to view to generate the MPC report. In Astrometrica, you have to select the View MPC report from the File menu and copy the entire MPC report to clipboard, and you have to paste the copied report into the submission box on your team page. Make sure the correct image set name is selected in the drop down menu. Make sure your citizen scientist names are checked. This process can be seen in more detail in the a PDF titled Submitting Reports, that is also a part of the quick start guide. Now, when all the information is correct, image set name, citizen scientist names, copied MPC report, etc., etc., you have to click on Submit Report. When you have submitted the report on the IASC website, return to Astrometrica and go to the File menu, select Reset Files to clear the MPC report and get ready for a new image set. Now, if an image set does not have any moving objects detected, an MPC report must still be prepared. To generate the complete heading in Astrometrica, you need to click on something, any star or anything in the image, and take a measurement. Assign it with a generic designation like XXX and 4 zeros. This will create the full header in the MPC report. Then you will copy and paste the report in the submission box on your team page, and you can delete the single measurement and add the line no moving objects detected. The report should look similar to the one below, just in the given MPC report. Just like that, you have to prepare the MPC report of a image set with no moving objects, neither known nor unknown. Now, you have to submit all the completed MPC reports on your team page on the IASC website, and you should not submit the MPC reports to any other location. Now, true and false signatures. As important key to a successful asteroid search campaign is being able to identify true and false signatures for moving objects. Not all objects that appear to move in the image sets are asteroids. You see that all objects that appear to move are not asteroids. Some are artifacts, some are other objects captured in the image set, etc., etc. So there are various possibilities. That is why you should learn to differentiate between a true and false signature. Now, for an object to be accepted as a true signature, the object must have the 3 characteristics. The object should move along a straight line. The object should move at a constant speed. The magnitude should be fairly constant. And that's all. So that's all that are the 3 conditions that an object should have uh, to be measured as a true signature. So a simple test for your citizen science group is to place the edge of a ruler along the path of a moving object to check if the motion is along a straight line or not. If not, then the object is a false signature and should not be measured or included in the MPC report. So here you can see that there is an example of the moving object, and you can see that in all the 4 images, it's in a straight line. So that's how a real a true signature appears. The examples of false signatures, you can see that these objects here are false signatures. So there can be a line, or it can be a single dot, or it can be a moving object that can be seen in only one image. So these objects would be rejected because although they appear to move in a linear direction, their shape and graph indicate they are artifacts. So now we have to remember a few points about false signatures. That is, the false signature must not be included in the MPC report. False signature like artifact must not be included in the MPC report. You can see that this is an artifact that appears to be moving but is not moving. You can see that is while this may look like a small asteroid based on its movement across images. When you zoom, it appears to be an artifact. You can see that it's not clear and it's not having a prominent shape. Now these objects here are also rejected because the magnitude fluctuates more than 1. So here the magnitude, there is one magnitude m in the object designation window. There is one magnitude m, and if the magnitude fluctuates by more than 1, the object should be rejected. Now false signature saturation. So saturated objects must not be included in MPC reports. So this is the saturation from a bright star. Never measure and report these type of saturated objects. And then we have false signature. The object appears to be moving. However, this may be attributed to the location of the image grid. You can see the outline of the flickering stars is the last two images. You can see that here in the image given just below the 5th point. So here are some examples of artifacts, and these are not comets or spaceships. And in the 7th point, you can say that these are not comets or spaceships and should not be included in the MPC report. Uh, Also, bright stars with diffraction spikes and some objects there appear to be moving, but they are not false signature. They are false signature and should not be included in a MPC report. And also, here is that known objects do not need to be included in the MPC report, but it is better if you include them in your MPC report. So, so the manual search. So this is basically a summary of what we discussed all this time. That is, select data reduction on the toolbar and select OK in the coordinates box that appears. This function will find the reference stars in your images. Select known object overlay on the toolbar. Then select blink images button and zoom in twice to enlarge the image. Visually scan the blinking image for moving objects. Now it may be helpful for you to establish a grid search pattern. Now, and also please refer to the guide titled Instructions for Using Astrometrica for details on how to correctly measure an object. Now, you can see that there are some true signature examples. The following images show the examples of true signatures or asteroids. They can vary in shape, size, and brightness. The asteroids will be moving in a straight line with constant speed, and magnitude will not change greatly. The edges will be rounded, and the object will be darker at the center. Now, for submitting a report through the IASC website, uh, after analyzing the image set in Astrometrica, copy the MPC report as previously stated, and go to your team page. And here is a submit MPC report section. And then draw and select the MPC and select the image set which you are analyzing from a drop down menu. And in the MPC report box, you have to drop the MPC report and select all the name of the citizen scientists who have analyzed that report and click on submit. And unless there are no there are no true signatures in a moving object, you should not change the measurement lines. Now, here are some achievements in IASC asteroid search campaign. So these are some achievements of Trishul Observatory in asteroid search campaigns. So it was our first preliminary discovery, our first asteroid search campaign. The campaign name was Saptarshi India STAC, ASA Citizen Science Group. asteroid search campaign, April, and it took place from between April 5th to 13th, 2024. The object that we discovered, the preliminary object that we discovered, was P11T2JS. The designation given by us was TRO 0002. I was the team leader, and the team name was SS Citizen Trishul Observatory Ayub Academy. Now, our second time preliminary discovery, the campaign name was CV Divgan Memorial Asteroid Search Campaign. It took place between October 25th and November 19th, 2024. There were total three preliminary discovery from that asteroid search campaign, and we discovered two objects from them. That is, they are the P2 1NZ, 1NZ T P2 21X56. The designation given by us to the objects were TRO 102 and TRO 807, and I was a team leader, and the team name was Trishul Observatory. Next, we have Are We Alone in the Universe? This is another citizen science project that we encourage, that Trishul Observatory encourages its members to participate into. And Are We Alone in the Universe is a citizen science project led by UCLA SETI, NASA, and the Planetary Society as partners. UCLA SETI uses the largest fully steerable telescope on Earth to search for evidence of civilizations in the galaxy. In this project, we observe stars and their planetary systems at radio frequencies with the goal of detecting signals emitted by radio beacons or other powerful radio emitters. So far, 55,000 stars have been observed and over 82 million radio signals have been detected. Volunteers' task is to identify the most promising signals in our data, and here you will classify signals by matching them to the common classes of radio frequencies, frequency interface (RFI), and your classification will be used to develop artificial intelligence tools to accelerate the research. And what are the requirements for participating in this citizen science project? The requirements are pretty simple. That is, an internet connection, a Zooniverse account, and that's all. Now, contribution of citizens of Trishul Observatory in the citizen science project. Are we alone in the universe? So, as a part of Trishul Observatory's contributions to citizen science, I, Sanchayan Sarkar, had the opportunity to assist in making the project Are We Alone in the Universe more accessible by translating it into Bengali. This effort allowed the project to become the first NASA-affiliated citizen science initiative on Zooniverse available in Bengali, helping to bridge the language barrier and encourage greater participation from Bengali-speaking communities. So it was a privilege to contribute to the expanding the reach of this project, enabling more people to engage in the search for extraterrestrial life and the wonders of the space. So here you can see that that the list of team members is given, and I am also with them as translator of this project. And here is the a Bengali version of the project Are We Alone in the Universe? Now, uh, before going to start the next part of uh, of our today's webinar, I would request our Rudra Pratap Nandi. He's also a citizen scientist and and uh, a global finalist of NASA Conrad's Challenge. So I will request him to respond. And Rudra Pratap, now the screen is yours. You may start.
Hello everyone, this is good evening. This is Rudra Pratap Nandi from Bangladesh, an 11th grade student and a citizen scientist. Sanchayan, am I audible?
Yeah, you are. Now I am sharing the screen. Please let me know when
Okay,
the
okay, sure.
presentation is possible.
Okay, okay, sure.
Is it? Yeah, you may start, Rudra Dada.
Okay, okay, sure. Give me a time, please.
Yeah, sure, sure. Take your time.
So it's a very proud for me that I'm giving a lecture with for Trishul Observatory. Here among the stars. So our topic is how can an amateur make a real scientific discoveries? Some facts. Historically, science was seen as a domain of professionals. Shanchan, please go next slide.
Yeah, yeah, yeah. Is it visible? I've gone.
Yes, yes, yes. Yeah, yeah. Yes, visible. Today, anyone with curiosity and dedication can make real contributions. Technology and open data and open citizen science initiatives have opened the doors for an amateur. However, now the advancements of technology have changed this game. Open source data makes scientific research accessible to all. Technological tools like telescopes, satellite data, software are now affordable for amateur astronomers. Citizen science initiatives invite public participation in groundbreaking research. How amateurs can participate in groundbreaking research? It's a very good question. Citizen science volunteers contribute to real scientific research. Opportunities available across various fields: astronomy, biology, meteorology, astrogeophysics. Volunteers classify data, track phenomena, and even make discoveries. So, opportunities to make real scientific discoveries. Previously, we discussed about some citizen science projects through which we can make real scientific discoveries. Some more exciting citizen science initiatives are given below. So, number one, kilonova seekers, a project overview, search for transient of cosmic explosions. Requirements: a internet connection and a universe account. Contribution of the Trishul Observatory in kilonova seekers project. In research paper Kilonova Seekers, Stick Lesson 8I, so Sanchayan Sarkar and Shobhanacharya Sarji of SS Citizen Science Group and I, Rudra Pratap Nandi, acknowledged in a research paper. So they are active members of Trishul Observatory. Additionally, me and Sanchayan Sarkar working as a translator in Kilonova Seekers project to translate Bengali. Project 2, Daily Minor Planet. Daily Minor Planet is a NASA-affiliated citizen science project led by the Catalina Sky Survey team, which is situated in University of Arizona. Project overview: search for near-Earth objects. Requirements: an internet connection and a universe account. Galaxy Cruise project. It's a very interesting project. Galaxy Cruise is a citizen science astronomy project led by National Astronomy Observatory of Japan (NAOJ), in which ordinary people and scientists come together to explore galaxies. Project overview: classifying galaxies, requirements, internet connection, and account in Galaxy Cruise project website. So NASA Space Challenge. So it's our four. NASA Space Challenge is the world's largest annual global hackathon organized by NASA in collaboration with other space agencies. It brings together coders, scientists, designers, engineers, and space enthusiasts to solve real-world challenges related to data, Earth, and space exploration. Participants are in teams to develop and also in solo. Innovative solutions within a 48-hour time frame. What is NASA Space Challenge? Founded in 2012, it is an international innovation competition that makes plays simultaneously in multiple locations all worldwide. NASA provides real-world space-related challenges, often based on open data from NASA and other space agencies like European Space Agency, Japanese Aerospace Agency (JAXA), Canadian Space CSA, etc. Teams create software, hardware, data visualizations, and mobile apps, games, AI solution, storytelling projects, and more. The competition is open to students, professionals, and hobbyists of all backgrounds. No prior space knowledge is required. Winners at the global level get recognition from NASA and may have opportunity to present their work to experts. So this is four category. Steps to participate in NASA Space Challenge. Registration and team formation. Participants can sign up the official NASA Space Challenge website, choose a nearby physical location, or join a virtual challenge from a team, usually 2 to 6 people, or join an existing one. Challenge selection. NASA provides a list of all problem statements grouped into themes: space exploration, AI and data science, climate change, Earth observation, etc. Each team picks one challenge to solve. Brainstorming and idea development. Team research the challenge, brainstorm idea, identifying a solution. Mentors and experts are available to provide guidance. Teams decides how to build an app, simulation, a game, a hardware prototype, or even a storytelling project. 4. Development phase. 48 hours team work on coding, designing, and developing their solution. They may use NASA's open data, APIs, and satellite imagery. Some projects use AI, machine learning, data visualization, or IoT to enhance their solutions. Submission and presentation. Teams submit their project, including a brief write-up, a video demo, and a GitHub repository or a link to their org. Judges evaluate project based on creativity, impact, technical excellences, and feasibility. Local and global judging local winners is location selects top team for awards. First they select a team for a global nomination, then global finalists, and then global judging. The best projects from all locations are reviewed by NASA experts. Global finalists and winners. NASA announces winners across multiple categories such as best use of data, best storytelling, galactic impact, and best mission concept. Why to participate in NASA Space Challenge? Gain experience in space sciences, coding, AI and innovation. To work with NASA's open data and real world problems. Network with scientists, engineers and space enthusiasts. Winning project may get recognition from NASA and invitations to present at space-related events. Last year, a Bangladeshi team go there. Thank you. On behalf of Trishul Observatory, I sincerely thank each one of you for joining us today. Your presence and enthusiasm made this webinar a truly engaging and inspiring session. We hope you found our discuss insightful and they sparked your curiosity to explore the universe even further. A special thanks our collaboration speakers, their team who made this event possible. Your support and participation are what drive citizen science forward, making astronomy more accessible to all. We look forward to seeing in the future initiatives and projects. Let's continue exploring the cosmos together. Clear skies and happy stargazing. So this is our
So, also thank you to you, Rudra Dada, for
it's a nice
for
pleasure
yeah.
to present there.
Thank you on behalf of Trishul Observatory's team. So we thank you. We are very grateful to you as you were present in our today's webinar and you participated in this webinar as a speaker. So if anyone wants to participate in in any of the above mentioned projects and wants to know about them in detail, they may join Trishul Observatory. So thank you to everyone. That's all about today's session. A very very thanks uh, thanks to Sovan sir and Shubhankar sir. Shubhankar sir helped us to record our today's session, and also Ayub Academy. So they have been with us uh, for a very long time. So since Trishul Observatory's first uh, asteroid search campaign, they have been with us. Thanks to Pradhan Vidwa sir, founder of Ayub Academy. And that was all about today's